Okay, good afternoon, everyone, and welcome back to the Water Finance and Management webinar series. Glad to have you with us today. Andrew Farr here, Managing Editor of Water Finance and Management. It's my pleasure to be hosting our webinar this afternoon titled Evaluating the Total Cost of Ownership of a True Smart Utility Network, sponsored by Census, a Xylem brand. So, I'm going to get into our topic here in just a moment. I just want to spend a couple of minutes going over some housekeeping items. Also, I'll just give everyone a minute to get signed on with us today. We're going to start by launching a quick poll question right now. If you see that popping up on your screens, please just go ahead and answer that and then click that blue Return to Presentation button. This just helps us to get an idea of everybody who's online with us today. So we'd appreciate it if we could answer that. And just to remind everybody, we're going to have some Q&A with our presenter after the presentation. Of course, I encourage everyone on with us. If you have questions at any point, feel free to submit those. You don't have to wait until the end. You should see the questions box on the left-hand side of your screen. You can also kind of pop that box out to maximize that viewing window if you'd like. But at any point, if anyone has any questions, feel free to submit those, and we will be monitoring the questions that come in, and we will get to as many as possible at the end. So as I mentioned, our presentation today titled Evaluating the Total Cost of Ownership for a True Smart Utility Network. This topic, I think, is right up our alley for Water Finance and Management. We cover a lot of topics around smart metering, smart water networks. What exactly does that mean for utilities, and sort of the interconnectiveness of digital technologies that are being adopted. And I think the presentation today is really going to tackle some of those points from a financial perspective. I think we're going to get into return on investment and how utilities can actually what they should actually be looking for on their return for a smart water network in the short term and the long term. So really excited to get into some of that. So let me go ahead and introduce our presenter without further delay, Joe Rogers. Joe Rogers leads the software and services business for Census, as I mentioned, a Xylem brand. His team develops communicating products and software solutions for water utilities on their digital journey. Joe has worked at Xylem for 5 years, and Joe, whenever you're ready, go ahead and take it away.
Will do. Thanks for the intro. Hello, everybody. I'll just get into it here. So, any good investment strategy should seek to provide a good return. I don't think that statement should scare anyone, but I think importantly to measure it properly, you need to try to capture the right inputs, and also know, of course, where your working capital is coming from. I'll get back to this. Before we bring it back to the utilities, I wanted to use kind of a very basic example for those not so familiar. Admittedly, I had to go refresh my own understanding of a lot of this, since it's been a while since I took a finance class from some university, but I thought it'd be helpful to break down some basic concepts and use sort of a trivial example to introduce this topic. So hypothetically, I'm starting an ice cream truck business. I have a single employee myself. I scoop ice cream very well. I've got some very basic products, and I've noticed that my growth in revenue has kind of plateaued. So I'm looking at different strategies I can take to try to grow my revenue and increase my business. I need to consider, how long I expect to stay in business, and also a good estimate of what I want my returns to be. And then I also need, most importantly, to consider, will my efforts be net positive if I try to take some sort of investment strategy? So the typical way you can evaluate this is by looking at the discounted cash flow model and breaking this down. Essentially, this means there's a cost for me to gather working capital, and also there is an expected cash flow that I expect to receive. And pumping this into an equation, more or less, will help me understand if an investment is a worthy pursuit. So for my ice cream truck example, I've evaluated 2 different projects. Project A, I can go introduce new ice cream lines. Maybe they last longer in a freezer or in somebody's hand in an ice cream cone and take them out, so on and so forth. Or project B, I can go purchase another truck and hire a new employee and grow my business that way. I think any good finance professor in university would tell you that any positive NPV is a good investment, but for the sake of my example, I've decided that I can only choose one project, and if I evaluate it over a short NPV, it looks like purchasing better ice cream is the better investment opportunity. If I look at a longer term, the new secondary ice cream truck would be the better investment opportunity because it grows my business faster. Overall, if you take the upfront investment cost and subtract it from the projected cash flow, you can find your NPV evaluated this way. So just to summarize, I should do both projects, but I can't. I have to choose one. Since I expect my business to be along for 10 years, I'm likely going to go purchase the second truck. So bringing it back to this example, more utility focused, I think most importantly, which inputs are most important to track when you're looking at investing in a smart utility network. Some of the things most topical to us in our business is the cost of reading technology. So how many endpoints are out there in the field? How am I reading them today? Do I know what the cost is to go capture that device reading? Are there any other projects that I want to pursue in the future that are going to be dependent on that reading technology? Another input is, of course, non-revenue water. Are there unknown components of the system that are leaking this asset out and it's not being delivered to our end consumers? And then another very important input, especially when you look at our businesses globally, is testing and reporting. So am I operationally efficient when I need to go report on certain metrics, mandated by local governments or other regulatory bodies? How am I doing those today? Can I make them more efficient with the right investment choice? So in the following slides, I'm going to break down some of these considerations, and I've listed them in bullets here, and I'll just get into it. So I think communication technologies is a foundational component of any smart utility network. Anything that we plan to build on top that seeks to bring a good ROI needs to have a good solid base. So some of the things that should be considered when you're looking to evaluate any of these technology choices related to comms are listed out here. I'll go over them. The spectrum use profiles, what I mean by that is, what other devices or applications are being shared on this infrastructure? So am I deploying a network and communicating devices that will be shared with another city application, or am I using some spectrum that might be allocated for other types of usages like radios, communicating equipment for ambulances, things like that. And also a close second importance is the deployment footprint. So depending on the type of spectrum use will dictate what types or how much infrastructure I need to deploy to make this network successful. So there I have it called out as deployment footprint. So if I need many hundreds of assets to go collect the radio waves being tripped by any of our devices, then that's going to take a pretty significant hit against the future ROI of the network. Another important point here is service level agreements. So is the vendor that I select to help me deploy my smart utility network going to sign up for a service guarantee? If there is anything like that, how close are they going to get to guaranteeing 100% effectiveness and usefulness of the network over time? What are the penalties involved if they're not being met? And then another one, which is very important these days, is technology trends. As we see a lot of newer communicating networks utilizing IP-based transmission, things like that, there are so many new incumbers to the smart utility scene that the technology is changing really fast. So if I'm going to put up working capital to invest in a new smart utility network, am I going to have to replace that in the next couple of years because the technology I chose maybe is no longer relevant, or I have a business need in mind or some problem that I'm trying to solve that can't be solved using the technology that's going to change, if that makes sense. Another important thing to consider is the types of devices that are being deployed out in the field. This is kind of another layer on top of that communicating foundation I described previously. But so, we've deployed the network. It's a good foundation. It meets our expected infrastructure footprint and whatever kind of spectrum use. How are the devices going to utilize that foundation? Are there going to be lots of edge processing where we expect the device to do a lot of, intelligence out there to tell us what's going on our network, or are devices going to be, hammering the network really hard to send, very high throughput data, streaming applications, things like that. I think just generally though, a good application seeks to find a mix between both of these things, where if you have battery powered devices that need to last for a given lifetime, you want them to do some sort of edge processing to take advantage of the local intelligence, but you also can't put everything out there in the field, so you need to find the application that has a low enough latency to stream the information quickly when you need it, such as alarms or things like that in the field that you need to roll trucks for very quickly. I think this component is also very important to look at the long-term ROI. If you have radio endpoints that need to last a very long time, you probably want to lean towards more of the edge processing components, but for those that can be replaced very often, the streaming devices seem to be better suited for that. And of course, any of these applications feed into all the software solutions that we see on the market today. I think a good software solution would seek to maximize any of these foundational layers in a unique way. And what I mean by that is, sometimes when you bring multiple different vendors in, or if you have different solutions trying to leverage different technologies that they were designed for, you sometimes can dilute some of the advantages that going with a single approach would provide. For instance, if you have a proprietary network that transmits alarms in a very unique way, that specifically leverages, the network technology, whether it be mesh or star or anything like that. If you try to clobber in a bunch of different solutions trying to leverage different things, you kind of can dilute the application a little bit. Next, I've got some examples, just some specific considerations for software. And rather than having a couple bullets, I thought I'd use a good application from a utility of ours. So this utility placed what I call network native pressure sensors in strategic locations across the network. They use this to find misconfigured or failing pressure reducing valves. And based on the network's ability to transmit real-time information, sometimes alarms, we're able to pinpoint which pressure reducing valves were close to failure. And you can see just by the chart here, the quick up and downs telling us that there's some sort of damage being caused. We can go and pinpoint which station to go send trucks to. Conversely, if you didn't have an application like this, specifically utilizing the network technology and devices, you'd be rolling trucks and inspecting many stations all over the place until you could find a problem like this. I think the awareness of looking at the network holistically with devices that specifically can leverage the latency of the communicating technology allow these types of applications. Another application, and this one goes beyond more of just reading technology, it's more higher level. If you've already deployed metering endpoints that are collecting readings anyway, having a good software application that can pull that data into one place can help you visualize kind of where the water is going in and out of your system. So the smart utility network can tell you if I know all of this water of this volume is going into this zone, and I can measure all the points where I expect water to leave, some delta should become very apparent of where essentially leaks are occurring. So I can maximize the usefulness of the utility network by finding applications like this that would only be possible if I was placing sensors that lasted a long enough time in the field to try to highlight use cases and examples such as this one. This is the very well-known, non-revenue water case where, the sum of all the water in minus the sum of all the water going out tells us where the leaks should be happening, or at least centralize the location where we expect them to be. So another important consideration is, once we move beyond the essential clean water applications, analyzing what we've invested for the communicating network, maybe for the most critical inputs. Once we've deployed it, what else can we utilize that network technology for? Are there other applications for our utility to leverage specific capabilities? And the way you can do this is really just looking across the entire water cycle of your utility. So a good technology choice would be versatile enough to find applications in each component here. It would be robust enough so that you could deploy it in the far out regions where maybe there's no electrical access, where you need battery powered devices. And also, another important thing to think about is the roadmap of the given vendor that's selected for the smart utility deployment. The smart utility network deployment. If they're not forward thinking and looking at the different types of applications for the technology choices, then that's just something to be considered there. So from Xylem, we offer the FlexNet utility solution. It's versatile. It comes with a service agreement, primary license spectrum. We've built this for municipalities and utilities. This is not an application that was purposed for something else and then moved into the utility industry. Everything that the FlexNet solution provides is built with utilities in mind. Let's see. Just a couple of examples of where we've deployed this solution across the board with many of our utility customers. Originally we deploy this for the standard applications, reading, maybe some pressure monitoring, but after the base ROI is met and the utility seeks to push it a little further, they're going across their water cycle and finding applications from Xylem where we can pull in, new solutions to maybe business problems that weren't apparent before. And the only way you can do this is by having a good network technology that can analyze all these components in one place. So bringing it back to the beginning, I think most importantly, looking at the inputs for any investment consideration is important. Learning what's most important to your business and what problems you're seeking to solve up front is a very careful consideration that needs to be done. Looking at some of the things that the FlexNet solution provides maybe can give you some ideas of where you can maximize that return. And that's all I have.
All right, thanks, Joe. Great presentation. So since we have a bunch of time left, I want to try and get through as many questions as we can. And obviously, again, like I said up front, if there's anyone that has any questions on anything that Joe talked about or just anything in the realm of return on investment for smart water networks, this would be a good time to get those questions in. So Joe, first question, I want to cover again what is considered a short-term and long-term ROI for a utility. So kind of going back to your ice cream example at the beginning, maybe you were looking at over 10 years, maybe just again kind of recap for us, what is considered short-term for a utility? What is considered long-term, and how do most utilities I guess, look at that when they're looking at implementing a new piece of technology for their system?
Yeah, that's a good question. I think that answer will depend on the utility. So if there is an opportunity to, bump revenue because of meter changeouts, then, you can realize that very quickly. But if you are looking at, maybe a systemic non-revenue water problem or some issue with reporting that's going to take a long time to understand, then the long-term ROI should be considered. So I guess the general answer to that question is it depends, and you need to evaluate carefully for your utility what the best time frame is for that.
Okay, sorry about that, Joe. So let's say, next question. So let's say you've already invested in AMI and or a utility has already invested in AMI, and almost going back to your example that you were mentioning early on about keeping up with trends in technology and how technology can kind of get outdated. What if the utility has made the investment and then a short time later they're told the technology will no longer be supported by the network? How do you incorporate things like new expenses and new sort of interconnectivity? How do you incorporate that into financial planning?
Yeah, I think that one's important to consider upfront. Looking at transparency from the vendor about the network technology that they use, the types of messaging that they're putting forward in their marketing collateral about what they're using. A lot of the newer network technologies have a lot of information available online, so it's pretty easy to do a lot of research to see what technology trends are there. I would say, you definitely don't want to get caught in the situation where you've invested in something and you have to replace it a short time later. But back to the long-term versus short-term ROI, you should consider what sort of time frame would make the investment beneficial or not, and weigh that against the vendor selection and the technology trends that are out there.
Okay. Can you elaborate a little bit more on the trade-off between edge devices and streaming devices? So let's say if a utility has SCADA, is that streaming?
Yeah, SCADA application would be definitely more streaming. Typically with SCADA, you require a lot of back and forth with devices to confirm delivery. So the type of network you need for a SCADA application needs to be extremely robust and very low latency and often high throughput, whereas for edge type devices, which tend to be battery powered, the longevity of the asset is more important, and they tend to do a lot more things that don't involve a radio. So when you key up the PA on a device, that consumes a lot of energy. So if you have a device that needs to last 15 to 20 years to maximize your investment, you typically want to look for the applications that are trying to do some things on the edge, and they only utilize that radio connectivity when it's necessary to do so, such as alerting for alarm conditions or transmitting small bursts of pressure data, contrast to the streaming applications where the radio is always powered on and transmitting.
Okay, very good. So, and this might be a follow-up, Joe, for the earlier question I asked when we were talking about return on investment and do you look at short or long term? You kind of mentioned, well, first of all, it depends on the size of the utility. What size utilities generally get the best value, and how small can you really go?
Yeah, that's a good question. Thinking about that. I think that answer will vary wildly depending on the geography that you're deploying your system into. So if you're looking at an application for a system that maybe is spanning hundreds of miles, you want to obviously limit the amount of infrastructure that you have to place. And if you have a lot of infrastructure that has a lot of upfront capital investment and, of course, the operational costs that you have to incur to go and service all that equipment. So I, look for the applications that try to minimize infrastructure and maximize connectivity and coverage would be my answer for that. I hope I answered the question succinctly enough.
Yeah. And so now moving back into, I guess, the type of data that we're collecting and monitoring, I should say, and the sensors. So monitoring pressure and temperature, that of course seems like a no-brainer. What about technology for inline flow metering? Has that improved, would you say?
Yeah, so I can speak to the Census solution. So we have a inline flow meter that we call Hydroverse that is compatible with our existing radio technology. So the same smart points that we deploy for our Omni devices and iPearl and Ally and even SR2 can be retrofitted to work with Hydroverse with no special firmware or activation procedure. The flow meters are important, obviously, because of their application positions, but typically where you place these don't have power hookups so that you can place, a different type of reading solution. So by being able to use that same battery-powered radio equipment, you don't have to go into procurement to find a different type of communicating technology to go and cover those inline flow meter applications.
All right, Joe, next question. So what are the advantages to capitalizing investment in AMI versus, say, an annual as-a-service model?
That's an important question. I think that depends on how easy it is for the utility to find the dollars to pay for the solution up front. So if you can find working capital up front and wish to purchase the assets and manage them yourself, then there are solutions out there that do that. The Census FlexNet solution is one of those. There are also other solutions where an operational model makes more sense because you don't have the working capital up front to pay for all the assets. The Census Services offering also provides that, where we will come and purchase the infrastructure and deploy it and manage it for you, and even provide project management teams to make sure that it works all properly. It all depends on, really, for the utility, how they can find the income to pay for the solution. Most vendors have both approaches, and I think that's because the market has shown that some utilities find different ways to pay for this than the other. I think the need for AMI all comes back to the types of problems that you're trying to solve. You can automate your meter reading application to reduce the amount of operational expense it takes to gather that reading. But as soon as you want to do something more advanced, like resolve your non-revenue water problem with high certainty rather than estimates, then you need a communicating solution that, one, fits the financial model and can do it the fastest and cheapest, more or less.
All right, very good. Joe, good question here that came in from a utility representative. Looking at the battery requirements associated with smart meters, smart water networks, one huge long-term item to keep in mind is the planning and scheduling of assets as they age. The question is, what advice would you give a utility to kind of keep this on the horizon and not get caught off guard as assets age and reach the end of their life?
Mm-hmm. That is a good question. I would look for solutions, especially communicating solutions, that can be retrofit to work with many different types of metering assets. So if you have the need to deploy the smart utility network now or an AMI solution now, but you haven't capitalized on the meters in the ground yet, look for the radio devices that can communicate with many different vendors. That way, you can pretty much retrofit what's out there without having to do a complete and total meter replacement just to get your AMI solution.
Okay, moving on now. There's a question here on water loss and non-revenue water. So regulating your pressure can really help reduce real losses. But can you talk a little bit about, and again, I know this is kind of specific to census technology, but talk a little bit about how it would identify the leak points.
Yeah, for that case, the answer really is to place as many assets into the field that you can to measure every point that you have. So doing that strategically and keeping track of where you've placed assets becomes incredibly important. But if you know where the water is flowing into a given zone and where the water is flowing out, the accuracy at which you can determine where that type of non-revenue water is happening is dependent on how precise you can place the assets around it, if that makes sense. So if we're trying to draw the epicenter, like finding an earthquake, the more points where we can measure it, the higher degree of accuracy we'll have pinpointing where the problem is occurring. So for the census solution, what we would advise is, of course, put a metering asset on every service delivery point, and then try to put either a flow meter or a large, CNI meter on every input to zones. And as small a zone you can make, the better. But of course, that's not feasible in all cases. So, I think I just generally answer that question with, place as many metering assets with AMI connected devices out there as you can.
Now, Joe, this question here is, I think, similar to the one we just addressed a second ago, but on the question of the batteries and asset life cycle, that is. But talk a little bit more about how meter accuracy should be factored into AMI system ROI. I mean, obviously, we know that there's maintenance needed with meters and things of that nature. So how does all of that factor into determining the return on investment, whether in the more short term or long term?
I think that's an important consideration for the long term ROI, where if you have a less accurate meter versus a high accurate meter measuring the same amount of water for a very long period of time, just a highly simplistic example, if you have one device that is only measuring 9/10 of every gallon that's going through it, and then the other one is measuring 9.9 tenths of every gallon going through, over a long period of time, the amount of water you're billing for is going to be vastly different between the less accurate and the more accurate device. And so multiplying that efficiency, so to speak, across the entire meter population can have a pretty dramatic effect over the long game, and the longevity of the asset, pretty much. And then another important consideration there is what is the accuracy degradation over time. So in mechanical meters, typically over time, they tend to fail faster, or they get less accurate with long periods of time, whereas the static devices that have no moving parts tend to keep their accuracy pretty much for the lifetime of the devices out there.
Okay. This is kind of an interesting question here, Joe, that kind of speaks to, I think, how the technology might, I guess, relate to another utility system. I know Census, just being familiar with the company, you guys are obviously involved in the electric and gas utility markets in addition to water. Question here came in, if my department oversees public works, could I use this to kind of a network to tell me when trash cans are full, for example? So maybe if you would kind of speak to how this technology can maybe translate to other utility or public works departments.
Yeah, that's a very important consideration. I think that goes back to my comments around the versatility of the technology choice. So having the solution that can be adapted to solve those business problems, taking that up front and seeing what the vendor is providing, what types of devices can be repurposed for new applications. I'll say from the census side, we don't think of everything. And sometimes we go out and we find utilities that have found, creative solutions to some problems using the products already in our portfolio, like, measuring chlorine and automating some flushing applications, all doing it with the Sensus FlexSense solution. The trash cans example is interesting because typically the water utilities that we deal with sometimes aren't connected to the waste departments. If they are, it's unique. So the considerations of how to know when the trash cans are full don't happen very often. But looking at a solution that maybe has gateway technologies where you can apply many different types of sensors. So putting for that specific example, trying to tunnel through essentially the notification using a sensor device through the versatile network would be my advice.
Okay. What about customer service and customer satisfaction? How does that factor into ROI?
Ideally, if your people are spending their time on the phone with our tech support teams very often, then that's time they're spending with us instead of servicing their customers or their consumer base. So that's an important consideration. I would look for the vendors that have good and dedicated tech support staff that are responding quickly. I think along the same lines, the project management around the deployments for a smart utility network are very important to look at as well. What is a vendor willing to put forward to help the utility adopt the new technologies or help them through with consulting solutions to some of the business problems they know they have, so that they're not on the phone with the tech support department trying to troubleshoot devices when up front they could have spent more time with the vendor's project management team with training and things like that to kind of subvert all of that. I think for ROI that's important just because of the amount of time that's spent. Like where are people's best use of time being spent up front, and how long do you expect them to commit to learning how to use the network over time versus if you can tackle that up front with something easy to use, for example.
Okay, Joe. Interesting question here, and of course, I'm just kind of wondering from your perspective. Obviously, Sensus and Xylem, you guys have a lot of water utility customers. You guys are really one of the leaders in AMI and smart metering. And I'm wondering, what do you see when utilities go to implement these systems? Are they first installing AMI and the meter reading analytics, and then later on they might add in other things like pressure and other edge devices? Is that generally how it's done, or what's the method with which they go about implementation?
Yeah, I think the primary driver, at least historically, and it's changing a little bit now, has primarily been for automating the meter reading capabilities. So increasing the frequency at which I can see the incoming data versus, if you're manually reading or doing drive-by, that latency is much, much lower. And using that data to better service my customer base. So if, somebody calls in with a leak, I don't have to go schedule a vehicle roll to go pull the data logs. I can just go and log in and look. So those types of applications were typically the drivers. I think lately we're seeing more with service management. So doing remote disconnect type of functionality is important because there's a significant operational expense related to that. There's revenue opportunities if you can automate that using the network, and obviously maybe you still charge for those fees to the end consumers. And then pressure monitoring and just general network management and non-revenue water are kind of the newer trends, because a lot of the smart utilities out there, including ours, do those other applications very well. And now the utilities are looking at other applications for these networks that they deployed.
Okay, very good. And Joe, I know we're kind of I'm skipping around here with some of these questions.
No, it's okay.
There's obviously a lot of
I like the variety.
Yeah, a lot of variety, a lot of related subtopics under under AMI, obviously. But let's shift back and talk another question on non-revenue water. Should non-revenue water reduction be included in AMI ROI analysis? And if how so? Can you talk a little bit about that? And what about repair costs from leaks and breaks and that sort of thing?
Yeah, I think the answer is yes, definitely. You should be including those, especially if you consider the cost it takes to measure it without one of these systems. If you're sending out, or if you're doing it to a low degree of certainty, you might be missing something off the top all along. I think this goes into the long-term ROI strategy as well. If you're doing lots of inspections and lots of truck rolls to go and find these sorts of leaks, and that's costing a lot of money to do so. And I think, finding exactly or pinpointing exactly where the problem areas are and rolling the trucks more strategically to repair those leaks probably costs less money over time than, all the inspection, the error on top of a, less accurate measurement of this over a long period of time. Does that make sense?
Yeah, absolutely. Now, we talked about considering life cycle cost of assets when evaluating AMI business case and the ROI. I'm wondering how you might see a smart utility network as being used to extend asset life.
Yeah, this one I think is all up to the vendor. So if you have a radio technology that is going to last a very long time, if it's immune, so to speak, not everything is, but if the major underlying technologies aren't going to change and they're guaranteed not to change, then you're not going to be at least replacing that communicating asset. For the metering devices, the same thing applies, but of course you have a lot of vendor selection if you pick the right communications provider. Look at the companies that are providing long-term product warranties, that the products have the right feature set that will outlast the same kind of technology trends we see with the communicating networks. I think all of that longevity is important because you don't want to be out there replacing devices sooner than you have to.
Sure. Question here on warranties. What consideration should be given to product warranties when considering a smart utility network? And Joe, is there an industry standard, or does each manufacturer offer their own product warranties?
Yeah, I think each manufacturer offers their own, but I think some of the bigger players in the industry have kind of set the standard of what the warranty should be. Again, this goes back to the ROI of what you're trying to accomplish here. So if you are playing the long game and you want to make sure that you don't have to replace these sooner than later, pick the longest warranty that you can that fits the business model.
All right, and I want to ask you about, so how, when you talk about your RF towers that a utility might have, how many meters can each of the RF towers generally support?
Yeah, for the FlexNet solution, that depends on how tall the tower is, and of course, population density and the number of available channels we have. We have a RF planning team that typically look at many of those factors, and they try to maximize the urban density for the given tower. So, generally, rule of thumb, I would say, no less than 30,000 devices per tower we could easily support. Of course, the other consideration, and this is important when you're looking at different network technologies, is the rate of transmissions that you expect the network to sustain. So, an endpoint or a tower can support a given number of endpoints, but it can only do so if we know the endpoints are transmitting at certain rates. So if you're expecting high resolution data from the system, then the number of endpoints the towers can support is going to be lower. So you need to find the right give and take for the business application you're trying to solve that determines, back to the infrastructure cost, how many endpoints you need or how many base stations out there you need to support the application.
Okay. Yeah, Joe, this is kind of an interesting question. I'm not sure if you could address this. I'll throw this one at you, and you can see if you can take this one. Have you experienced any, and by you I mean Census or Xylem working with your customers? Have you experienced any local governments experiencing challenges in identifying capital versus operating costs as it might relate to software as a service agreements?
Oh, that's interesting. Thinking about that question. Not so much financially that I know of anyway, and then certainly we can take this question back and I'll circulate it to some others here. Mm-hmm. But I do know that more often we see resistance for the software as a service model from IT-minded professionals, where they're looking at how to secure their organization most efficiently. They're looking at their ROI for their IT assets. Do they want to outsource? Do they want to start outsourcing other components of their business into the cloud versus try to host it themselves? Typically, that's where we find the challenges moving towards a software as a service model, not so much versus capital or operating costs, and especially related to local governments. The only thing close I can think of is with our large investor-owned utility partners that we've deployed solutions to. Sometimes regulations do dictate certain methods of operating and where finance can be created to invest in solutions like this, but it's not specifically tied to software as a service arrangements. It's more about the overall solution and servicing the end consumer.
Joe, a question that comes to mind for me personally, just as we're talking through all of this, AMI and implementing an AMI or a smart utility network. As you even mentioned a little bit earlier, it seems like the primary reason, or historically and probably still now, that utilities are moving towards that is simply first and foremost to improve meter reading and accuracy and that sort of thing. That's first and foremost, and then they might add on some additional capabilities. We talked about pressure monitoring, et cetera. I'm wondering, in your mind, I guess aside from the metering aspects of it, what tend to be other pain points that utilities are trying to, separate from metering, are there any other pain points that you see utilities having to address, like that are consistently coming up in discussions between you guys and your customers?
Yeah, new ones are coming in all the time. Some of the more recent ones that come to mind are around, measuring and reporting of certain quality measurements, and automating some of those tasks so that they can be done more efficiently and more often. I can think of one example where it's one individual's job for the entire year to measure chlorine concentrations at certain points in the network and then report them back, and it takes a lot of effort to go and do that application. Finding the right field assets that can last in the field so you don't have to go replace them, and battery lasts long enough where you can take those rapid snapshots, can automate a lot of that work, and that person's time can be better spent analyzing the data and making recommendations rather than just reporting. So the trend I see maybe is moving away from just capturing the data and putting in a report to capturing the data, putting in a report, and using it to make recommendations for operational improvements over time. And I think that's a very important consideration when you're looking at the ROI of the total smart utility network. What can you use the data you're collecting for to better optimize and improve the overall quality of the system you're running? Hopefully overall that maximizes your consumer satisfaction out there. They're getting cleaner water. You can operate a better service department for everyone, and you're also trying to reduce your own costs because you don't have to keep measuring all these things all the time. You can start automating and make better decisions about how you manage the business.
Okay, let's go through just a couple more questions. So you mentioned AMI technologies that can read multiple vendors of meters. We've talked about that a little bit. I'm wondering if you can elaborate on that and whether or not that only applies to AMI or would that also apply to drive-by AMR as well?
It can, yeah. So picking the right radio device that can be retrofit with the metering device is important, and then externally how you're communicating with it is also beneficial. I think when you're looking at maybe migrating from an AMR solution, this becomes a lot more important. If you don't want to go and replace all the radio equipment up front and maybe do it slowly over time, there's going to be an operational need to read all the equipment in one place rather than reading for two separate routes, for example, because that's going to create some difficulty. So looking for vendor applications that can read multiple different types of endpoints for AMR is important. For the AMI side of the house, that's a little more complicated because typically the network technology is dictated by the vendor. Even for the cellular options, each of the vendors tend to bring their own flavor of reading technology. So for AMI, that becomes a little more complicated.
Okay. And so this question, a couple questions here. I'm not sure exactly if I'm phrasing this the right way. Maybe you'll be able to pick up on this one, Joe. So obviously, most of our discussion has been about automated information gathering. It's essentially the benefit that AMI provides. What types of automated system controls are available for utilizing all that data? Does that one make sense?
Yeah, it does. Maybe the system controls piece is throwing me off a little bit, but I think I take that to mean, so we're collecting all this data. How are we telling the utilities what to do with it?
Right.
We look at, some. I think Xylem tends to go for some of the low-hanging fruit, so to speak. So for like the census application, for the Ally application, primarily it was driven by automating the business operation of truck rolls to turn on and off accounts or reduce valves, or for vacation properties where the account goes inactive. That can be very expensive for utilities. So the way that we bubble that up is in specific applications that are tied within our application ecosystem, and that allows us to kind of rapidly listen to what business problems the utilities are trying to solve, and then we can try to tailor specific applications for those needs. I think tying them into the vendor solution, there's pros and cons to it. I think some strong pros are if there's like a specific application that can be best seen by the given network technology, then it makes sense to leave it in the vendor's ecosystem. So like the Ally example I threw it out, that relies on the low latency characteristics of FlexNet. So we have a tailored application within our ecosystem that helps the utility automate that task. We also have another one coming down that specifically leverages the way that we transmit pressure and temperature data across the system. And we try to bubble that up in an insightful way for the utilities in some streamlined software applications in our cloud. And if we want to take that question offline, feel free to send me an email. We can discuss more. I'd be interested in hearing your thoughts on how I interpreted that question.
Yeah, absolutely. If just to remind our audience, if there's anything that we're not quite making clear, there's anything that we don't get to, Joe and his team at Census can certainly follow up offline with any questions that, like I said, we didn't address exactly. But Joe, a good question came in here from a utility a little bit earlier, and I thought it'd be a good one to end on. But AMI has really revolutionized the way water utilities monitor and even charge for water consumption. And there's been a lot of advancements, I think we know in just the last 5-10 years or so. What do you think the next big breakthrough will be? And do you see AMI continuing to evolve, or will a completely new system or process emerge? What do you think the future holds for that?
Yeah, that I could probably talk about this for 30 minutes. I think, I think billing for end customers, at least in our country, is not going anywhere. In purely equitable society, we would not bill for water, and everything would be provided and clean and perfect. But that obviously isn't the case for now. But I think the next big breakthrough will be, moving to monitor and control the other assets within the water distribution cycle. So, we've pretty much narrowed down on the reading application, and now we see there's a little bit of control to automate some business practices with the service connections. We're moving into pressure monitoring. I think the next big breakthroughs will be more on the solution side, where we're finding new ways to look at this data and either automate or optimize or provide valuable insights into what we're seeing happen in the water infrastructure. And then I think those breakthroughs won't be all-encompassing for like the whole country or globe. It'll be very specific to the utility and the geographic region. So, for example, if you have an aging water distribution system with, old pipes, you might try to utilize this data to help you find where maybe the water quality is very poor, or connectivity analysis leads you to believe you have some other types of problems, and contrast that to other parts of the U.S. where water scarcity is becoming a pretty big issue, and we need to make sure all the crops are watered and still people have clean water to their homes. So those types of application or those types of business problems are going to drive different applications. So it's really difficult to say, concisely what the next big breakthrough will be, because I think there will be many, and it'll be totally related to the different challenges related to water that many of the different utilities are experiencing, which vary wildly, as I'm sure everybody knows.
All right. Yeah, great perspective on that, and I agree with you. It's definitely a question we could probably spend another half hour, a lot of time pondering, but we'll see what happens. Definitely a lot of exciting things going on in the industry around AMI right now. There's no question about that. But Joe, thanks again for the great presentation and for sticking around for some extended Q&A today. and like I mentioned to our audience, if there's anything that we didn't get to or anything that we need to address offline, Joe and his team will certainly follow up with you. So I'd like to thank everyone for signing on with us and joining us for today. Thanks again to Census, a Xylem brand, for sponsoring today's webinar. This webinar will be archived on our website, the Water Finance Management website. If you're not familiar, waterfm.com is our website. You can refer back to it if you need to. And with that, we'll go ahead and close. Thanks everyone for joining. Look forward to having you on the next webinar.